Hello everyone, and welcome to an example solution for the Logistic Regression Consulting project. Let's open up the notebook and get started. Okay, here I am at the notebook. So we have this customer churn CSV file that we want to build a model off of, and then later on we also want to compare it to this new customers.csv file. So we're going to run this, and let's start a Spark session. So from PySpark.sql, we'll import a Spark session, and then let's create one, Spark session, builder, app name, and I'm just going to call this logreg consult, and then get or create that Spark session. So we run that cell, and now let's load in our data. Our data is just a CSV file, so we can say spark.read CSV, and I'm going to grab the customer churn data. So that's customer churn.csv, and I'm also going to infer schema, and I will say that header is equal to true. And now let's check out the schema of our actual data by saying print schema and running this. So here we have the schema. We already went over it in the previous lecture explaining it. So what we can also do is say describe if we want to see some more information about it. We're pretty zoomed in right now, so we probably get some weird behavior, but let's just see it out. So data describe.show, make sure you have closed parentheses here, and we can zoom out just a little bit to see this. And we can see here we have 900 counts, and it looks like we have 900 counts on all the columns, so we shouldn't be missing any data. As long as everything is there, we can continue along. So what we're going to do is check out the columns we're going to be working with. Data.columns, and we can zoom in one more, whoops. Data.columns, and then what we want to do is actually select stuff for the vector assembler. So I will say from PySpark ml.feature, import the vector assembler. And then I'll create my assembler object, and I will set it equal to vector assembler, whoops, and I want my input columns to be the following. I'm not going to use names because it's pretty arbitrary. The age of the customer, it's a numeric, so it might be pretty useful, as well as the total purchase, maybe whether or not they have an account manager. I don't expect that to actually help because remember, in this data that's randomly assigned, but it's easy enough to include numerically, so we can include it. And then years and number of sites. So let's select those. I'll copy them and then paste them in here. And let me make sure that's a closed string. So there are my input columns. And the next thing I want to do is select this all to be the output column of features. So we'll run that. And now that we have our assembler object, let's create the output to be equal to assembler. And then we're going to transform our data. So we have this output. And now let's create our final data set, which is just going to be that output, and all I want to do is select the features and the churn column. So we run that, and now we're ready to actually split this into our training data and our test data. So we'll call this train churn, and then we'll say test churn, and set that equal to this final data. And whoops, let's do a random split. And we'll do a 70-30 split. Run that. And now we're ready to actually perform our logistic regression. We'll say from PySpark.ml.classification, import a logistic regression. And then what I'm going to do is create a model for logistic regression. We'll say lr_churn is equal to an instance of logistic regression. And the thing I have to clarify is that my label column will be equal to the churn column. So we have that going. The next thing I want to do is actually fit this model to the data. So we'll call this fitted churn model, and I will grab lr_churn and fit this to my train data, which is train churn. So that's fitting right now, and what I can do after this is check out a summary. So we'll create some variable called training sum for training summary, and this will be equal to this fitted churn model summary object off of it, and let's check it out. I'll call my training sum, and then call the predictions off of this, and then call describe.show. And this is just to explore a little bit. You don't have to do this if you don't want to, but I can see here that my prediction mean, prediction standard deviation versus my churn mean and churn standard deviation. So what would be nice to do here is actually do some evaluation metrics. So we'll do these evaluation metrics against the mllib evaluation and our test data. So to actually do this, I need to say from PySpark.ml evaluation, and I'm going to import, since this is a binary classification evaluation, I'll import that. And we'll call this new object pred and labels, so for prediction and labels. And that's going to be equal to our fitted churn model evaluating the test churn data. Now that I have this pred and labels object, I can actually grab the predictions off of it. So we can say pred and labels predictions, and then I can show the results here. Let me zoom out so we can see that entire data frame when I run this. And I can zoom out one more time so we can see the whole features. So I have my features column, the churn value, that's the true churn value, the actual label, the raw prediction, the probability, and then the prediction itself. So we can see here a lot of these predictions are matching up to be zeros, which is good. All of these churn values were 0, but it looks like we're already missing one here. So what I want to do is actually use this binary classification evaluator to check the area under the curve. So let's do that. I'm going to continue on here. Whoops, scroll down a little bit, and let's zoom back in. Scroll down, and then let's call that binary classification evaluator. So let's create an object, call churn eval, and set that equal to binary classification evaluator, where my label column is equal to churn. And I can set my raw prediction column. So raw prediction column equal to prediction. So I have these two columns here. Once I have this evaluator object created, all I have to do is pass in that predictions data frame we just worked with. So the default is area under curve, so that's going to be my variable name. And I will grab this churn evaluator object, and I will evaluate the predictions, or pred and labels, and then call predictions off of this. Run that, and then let's check out our ACU, see how we did. Or AUC, excuse me. So it looks like we have a 0.68 value for AUC. That's not so bad. It's not super great either. Remember that a value of 0.5 would just be as good as randomly guessing. So now that we see the area under the curve, the next step is to try to predict on new data. So if we scroll all the way back up, remember that we have this new customers CSV file. So the area under curve is performing well enough that we can evaluate on this sort of like holdout data set, which essentially doesn't really have labels. So it's not truly a holdout data set. It's more like a model deployment. So we'll scroll all the way down here. And what we're going to do is, let's just create this and say predict on new data and run that. So we'll create some sort of final model. So final LR model, and set that equal to our LR churn model. And I'm going to fit this on all the data, not just my training data or my test data, but what I'm going to do, so if we scroll back up here, I'm going to fit this on all my final data. So I will copy that and then paste it in here. So we'll fit on all our final data, and then what I'm going to end up doing is read in that new customer data. So we'll say new customers is equal to spark read.csv, and that's new customers. And I'm going to infer schema to be true, as well as set header to be equal to true. So we'll run that. And the next thing we want to do is make sure that new customers is in the same format. So I can say new customers.print schema, check that out. And it looks like everything is exactly the same format as before. So that means we're ready to go. So what I can do is say this test on new customers is going to be equal to my old assembler object. And now I'm going to transform this new customers object. So here's my new customers test. And then the other thing I have to do now is confirm that it has that features column. So I can say test new customers, and then we can print schema, and I should see a features column all the way at the end. And there it is, features. It's a vector of those features from my assembler object in the beginning. And the next thing I want to do is transform this. So we'll say final results is equal to that final LR model, and I will transform that final data. Well, actually, our new data, so this new customers CSV. So let's make sure that we have that. It was test new customers, excuse me. So test new customers, we're going to transform that data set, run that, and then let's check out the final results. So if we show these and we can zoom out a little bit, We can see here we have all the information, but what I really care about is the churn prediction, which in this case is just called prediction. And if I wanted to format this nicely, I can also grab the names. So maybe we can grab the company name as well. So showing that, here are basically my predictions for the company and then these guys. So my actual data set for this new customers wasn't so big. In fact, we can see from test new customers, if we ask for a describe method on it, and then show the results there, there's actually only 6 customers here. So these are my predictions for these customers and whether or not they will churn. So it looks like I predict 4 of these customers are churned, meaning these are the customers that I should assign account managers to. Now, if you didn't get the exact same results, that's totally okay. It really depends on the random split, but hopefully you got similar results. At least half of these should match up to what I have here. If you have any questions, feel free to post to the Q&A forums, but also definitely check out the Example Solutions notebook, which goes into a lot more detail than what we've shown here. Thanks everyone, and I'll see you at the next section of the course.